We're going to look at one more monitoring progress question that goes with example 4, solving real life problems. And this is where we're going to find the zeros, or we're going to find out when does the object hit the ground. So first we need to make sure we're starting off with this formula, f of t equals negative 16t squared plus s sub 0, where s sub 0 represents the initial height. We are going to do monitoring progress number 7. It says, what if the egg dropped from a height of 100 feet? After how many seconds does the egg hit the ground? So we're going to do number 7. I already wrote the formula on our paper over here. And we know that the egg is dropping from 100 feet, so that's going to be our s sub 0. S sub 0 equals 100. We're going to plug that in here for s sub 0. We also know that we want to find out when does the egg hit the ground. That's our f of t, that's the height of the object. So we're also going to plug in f of t equals 0 into our equation. So now our equation looks like this. We're going to have 0 equals negative 16t squared plus 100. So now we're going to graph this. So to graph this, we're going to make a t-table. So in our t-table of values, we're going to have x and y. And remember, we can't have negative time. So we're going to start with 0 as our first x, and we're going to keep going up from there until we get a y of 0. I'm going to use my graphing calculator to help me do this so that I can do this a bit quicker here. We're going to go into y equals. Let's plug this equation in here. We're going to have negative 16t squared, and we don't need to type in t, we can just use x squared, plus 100. Let's do second table, and let's start filling in our numbers here. So 0, our height was at 100. 1, our height was at 84. 2, our height is at 36. Now when I get to 3, my height gets to be negative 44. So I can't have a negative height. That doesn't make any sense. I know that it's going to happen sometime in between 2 and 3 seconds. So the best way to do this is I can look at the graph. Let's hit second graph. Graph. And let's look over here to find out where does this point hit the x-axis. Now, if I try to move my cursor, I can see approximately where it is, but I can't get exactly on that number. It's somewhere around 2.5, but I don't know exactly what it is. Let's see if we can figure out what the number is. I'm going to now try out a function in the calculator to plug numbers into our equation. So to do that, I'm going to hit second, calc, which is right above the trace key up here, calc, and then I'm going to choose number 1, value. Let's try 2.5 and let's see what we get. And that's definitely it. That's when our y is going to be 0. So I'm going to add that to my table here, 2.5. That's when our y is going to be 0. So that means that the egg will hit the ground in 2.5 seconds. The egg will hit the ground in 2.5 seconds. Now we could graph this by hand as well, but I already did the graph in my graphing calculator, and it doesn't actually say that I have to graph it here, so I'm not going to graph it. I do want us to look at some other questions of how we can find this answer without using a t-table or without using a graph. So I'm going to take a look at some other problems here. So this is, just consider this 8.2 notes. We're going to find the zeros of an equation that looks like this, y equals ax squared plus c, without graphing. The first thing that we want to do is we want to plug in y equals 0 into the equation. We want the equation to equal 0 because we're finding the zeros. The next thing that we can do is we can solve this quadratic equation. We can solve this quadratic equation using something that we used back in chapter 9 in section 3. We can solve using square roots. Okay, we're gonna look at some examples, and I'm getting these from the 8.2 exercises from the textbook, and these are just like the big ideas problems that you have assigned. So our first step is I'm gonna plug in 0 for the y. This is number 19, y equals x squared minus 1. Let's make it 0 equals x squared minus 1. I wanna solve for x using square roots. Let's isolate this x squared. So my first step is I'm gonna add 1 to both sides here. Now I have 1 equals x squared. Okay, to solve for x, I need to get rid of the square on the x up here. So in order to do that, I need to take the square root of both sides. So when I take the square root of both sides, I get x equals, and remember that the square root of 1 is not just 1. Remember, it's positive and negative 1. So it's positive and negative 1. I can write it like that. Or I can say it like this, x equals 1 and x equals negative 1. So I do get 2 answers here. Let's look at another example. We're gonna do number 23, f of x equals 4x squared minus 16. First, we're gonna plug in 0 for y, which is the same thing as f of x. 0 equals 4x squared minus 16. Let's solve for x squared. Get rid of the number being added or subtracted first, so let's add 16 to both sides. 16 equals 4x squared. I still need to isolate x squared. Let's divide away the 4. Divide both sides by 4. I get 4 equals x squared. Now let's solve for x by getting rid of the square, and I'm gonna take the square root of both sides. Don't forget that the square root of 4 is positive and negative 2. So those are my 2 answers here, positive and negative 2. If I want to go back to that monitoring progress question number 7 that I just did, where the egg is going to be dropped from a height of 100 feet, how many seconds does it hit the ground? Just want to remind you of the equation we started with was 0 equals negative 16t squared plus 100. Let's solve this using square roots. We're going to start by subtracting 100 from both sides. Negative 100 equals negative 16t squared. Next, let's isolate the t squared. We're going to divide both sides by negative 16. I'm going to use my calculator to do this. When I do negative 100 divided by negative 16, I get 6.25. And it's a decimal, that's totally fine, equals t squared. Let's solve for t. I'm going to take the square root of both sides here. Okay, when I take the square root of both sides, I'm going to get my answer for t. So let's take the square root of 6.25. And I get 2.5. Now, technically, it's positive and negative 2.5, but because we're talking about time here, it can only be positive time, and that's why it's 2.5 seconds.